It's recording.
All right.
Yep. Alright.
Welcome back from the break. So we're going to dive into learning objective number 4. It's going to be going between two different kinds of streams and nozzles. So a few different kinds. So we're going to go for that. Factors that affect the hose stream is going to be the velocity of the water and what you're spraying. Cast is going to be, it's going to have less friction loss. But it's going to be affected by, it's going to be diluted with foam, so it's going to be affected by lots of things, wind, but the velocity of the water, how fast is that water going when it comes out of the nozzle, that forward momentum. If it's higher pressure, it's going to go a lot farther than if you have, no pressure and you're leaking out the end, or if your nozzle is too big and you don't have enough pressure, it's not going to, push that water.
Little limp.
Yeah.
Hey, limp.
Yeah. Upstream.
Stop the flow. Sorry, go ahead.
Flow rate of water, the extinguishing agent, like I was saying. How much water are you moving? That's gonna change it. We messed with our stack tips on the aerial on that truck too, and we're just seeing what was like the maximum reach we could get, and I don't remember what we got down to, but we took a few off and pumped it up, and it was spraying probably 150 yards, and it was windy that day, and it was launching water. But we increased the pressure, and then we were changing that tip to see exactly what the most reach we could get with it. Gravity, so spray it, it's going to eventually come down. It's going to break it up. Wind direction and velocity, if it's a really gusty day and you're spraying a broken stream, it's not going to go nearly as far as if it would be a solid stream, because it's going to hold it together. It's not going to blow it out. Especially a fog stream is going to be, it's not going to go very far at all if it's 40 mile an hour gusts out there. Air friction, yeah, I guess. It has something to do with it. It'll slow it down. The operating pressure, how much that's going to go with velocity of the water, how much pressure behind it is pushing it to how far is it going to go. Nozzle design and adjustment, is it smooth bore, fog nozzle, broken stream, adjustable, what are you pumping water out, and that makes a big difference. And the condition of the nozzle opening, has it just got filled up with a whole bunch of stuff in the house, it dropped in the mud and got a rock stuck in it and made a big cut in it, or is that fog nozzle clogged up with gum and stuff because it hasn't been cleaned in a long time. Hose stream uses, applying water, foam to burning material to reduce the temperature. That's our job. You can cool it down. Just taking something out of the fire triangle there, you're cooling it down, so you're breaking that cycle, and it's going to reduce the fire and reduce the environment for the occupants or the firefighters ourselves. Applying water, foam, and open flames to reduce temperatures of fire can advance hand lines. Yeah, it's the same thing. You're cooling it down, making a better environment. That way you can advance to wherever it started, the seat of the fire, or maybe you're at the seat of the fire, but it's going to be knocking it down. Hose streams, the uses of them, it's going to be reducing the temperature of the upper gas layers. So flashover chamber, you're setting it, you can see those fingers coming out over the top of you. It's hot. Like, you hit it with a stick and it's 1200 degrees. You can cool that down. They did a study. I don't have the name of the person that did this. Oh, it was like an insurance agency or something. They were doing studies on rooms, and they were saying if you coat a room in water for X amount of seconds, like open your nozzle and just spray, they kept doing this over and over again, trying to get this room to flash, or not to flash, but to see how long it would last in this environment. And by the end of the day, they had to take all the carpet out and put new carpet in because they couldn't get it to flash. They couldn't get it to do it. So the more water you flow, you're going to be reducing that upper layer of gases where all that fuel is. You don't want it coming down on you. You're dispersing hot smoke and fire gases from a heated area. You can do hydraulic ventilation, take a window and spray it out. They were talking about fog streams later on in the chapter. Yes, it's going to push a lot, but you can do it with a smooth bore. You whip it around. If you whip it around, it's going to entrain that air. It's going to be pushing smoke. I mean, that's what we do. That's usually what we deploy at twos is smooth bores. And if you whip it, it's going to take it a lot more. If you put a straight stream, it's still going to pull air, but it's not going to send it. And the same way, I'm kind of getting ahead of myself, but if I don't remember to say it later, if you're spraying in a house, like say you were first one there's nobody coming for a little bit, so you're gonna knock it down from the yard. You don't want to put a smooth bore in the. You definitely don't want to put fog in there because you're reverse hydro venting it. You know, you're pushing air in. So if you're putting it in the window, you want to get like as close as you can, put it as straight as you can, and don't move it. Like don't whip it around and stuff, because then you're pushing air into that structure, making the fire worse for everybody. So, creating a water curtain to protect firefighters from heat and property. We're talking about fog nozzle. You know, it spreads out, it increases that surface area of the water. That water is going to soak up the heat, the radiant heat. So it's going to protect you if need be. What would be an example that we'd use that for? Like a water curtain, I guess.
Propane tank.
Propane tank, okay. Yep, you go in and shut it off, firefighter 1 and 2 skill. It can create a barrier between fuel and fire. I'm thinking of like roll-on, for like, you know, a oil spill or whatever, you roll it on that foam, and it makes a barrier so it's not putting off the gases so the heat can't burn anymore, so that's how you put it out. And then hydraulic ventilation, there we go. So I hit that up there, so I just got to hit myself a little bit. Describe hose streams, the patterns they form. So we've got smooth bore, fog nozzle, broken stream. That's the main three. Nozzles that create the patterns, the types of controls. All right. The types of control valves. So we got the ball valve. We got the slide valve. That's just what's going to open the nozzle, allow that water to come out. And factors that limit the hose stream. So what do you guys think factors that would limit it would be? Pump pressure, yep.
The wind.
The wind, yep, very good. Yep, wind, especially for like a broken stream, or even a smooth stream out of an aerial that's on a windy day. Stream quantity and reach. So it's going to be size of the nozzle opening plus the nozzle pressure, and then that's going to be the quantity of water flowing from the nozzle. So bigger nozzle, low pressure, you're getting water out, but it's not effective. You increase that pressure, you're going to get the maximum amount of that orifice. But if you have a ton of pressure in a tiny hole, it can only go out as much as you know it is allowed to. So the size of the nozzle opening and the stream reach makes so like that's kind of like fog nozzle. Fog nozzle, it disperses pretty fast if you have it wide open. If you have a smooth bore, a solid stream of water, it's going to be going forward, and it's going to reach a lot farther. You can hit the fire in the face from way back instead of having to get right up on it. I tell them pro smooth bore, don't I? Okay.
Most of us are.
Yeah, smooth or not smooth. See, it is a solid stream. It's a good one.
Well, when we
So,
ever use.
yeah.
Use fog in there.
Yeah. So yeah, this guy's doing a one-man push,
45, 50, I think.
holding the pistol grip. He's doing good. So
Fog guy. Called me a card first time. I was like, you're gonna go.
So fog nozzle in the straight stream, you can get either one out of a combination. Left is for a wide fog, right and it'll go into more of a straight stream, smooth bore type. The NFPA manufacturer recognizes nozzle pressure produce variable hose stream patterns as adjustable patterns. Spray nozzles for the purpose of the manual. We use these more common term among the fire service. Fog nozzle to describe these. So we're going to call it fog nozzles today. So I think that's pretty across the board. at least here anyway. So, now we're talking about water. Why do we use water to put stuff out? Well, it's readily available. We have hydrants. We're lucky enough to have hydrants all over town, almost on every corner. You can get that water and say if we're doing a high rise, JQH is on fire or something. We can have CU boost our pressure to that area and it'll pump it up so we can get the amount we need. That's why we do all the occupancy inspections so we know how many millions of CFM we need.
Yeah, that's one. I think it's a guesstimate on the number.
Yeah.
No.
And it's relatively inexpensive. I mean, it comes from somewhere. It does cost money, but
We don't see that.
compared to dumping foam on something, foam's expensive. And
Cancer.
you have to have the, yeah, it's hard on us too. But you have to have the equipment to use it. Water's,
None of that.
I mean, they've been putting out campfires with water for forever, I guess. Greater heat absorbing capacity, the most common extinguishing agents. So it sucks up all the radiant heat really well. I mean, it does its job. So can't complain about water. Absorbs a large amount of heat when it changes to steam. So the steam conversion is at 212 degrees at 1700 times, and that increases if it goes up. So if it's 500 degrees up there, I'm not sure what the calculations are, but it's gonna convert to steam. So you gotta worry about, especially the fog nozzle, steam yourself. It can be applied in a variety of ways. I mean, just the different nozzle types. It can be fog, it can be straight. Oh, there it is. Like I said, water, and that's 212 degrees at that point, which is what? Boiling. Good. All right. Good nozzle control and coordination and tactical ventilation make effective, efficient, and safer hose stream operation for the fire control.
True.
I agree. Why is water an effective extinguishing
Does
agent?
it expand 1,700 times?
Okay, all right.
It's readily available.
Ready available.
Yeah.
Inexpensive.
Cheaper.
Very good. Mr. Dawson.
Yep.
All right. NFPA 1963, standard of fire hose connections identifies two general categories of hose stream nozzles: straight tip nozzles, spray and spray nozzles, which again they're going to be called fog nozzles, or smooth bore fog nozzles. So that's just what we call them now. The hose streams. Smooth bore, fog, broken nozzle streams, they're what control what the water does once it comes out of your hose line. It's going to shape them. It's going to allow you to reach out and get the fire, or be able to put a water curtain up and keep that radiant heat back. The inlet, outlet, and the mass of the water is going to be it's going to create reach. It's going to shape that hose stream, so that's why. We got a couple smooth bores here. I think we have some of those relics on a couple of apparatuses, and these are more common. So, smooth bore nozzles, you're going to operate them at lower nozzle pressure. We have 150 psi at the tip, and then for a master stream, you're 180 at the tip. That's going to get you your optimum handling and performance. You're going to be less prone to clog with debris. They have a big orifice, lots of water can be pushed out. So, like fog nozzle, you might stick it in the mud, and then, you could mess up, possibly. It can be used to compress some calves, compress air foam. That's what we use if we use calves overhaul, I guess. We allow hose lines to kink because it only has to be 50 psi at the tip, so you're going to have less hose pressure. You're losing like 13 per 100 on an 1 3/4. So, yeah. They may allow hose lines to kink. Do not allow for selection of different stream patterns. So you're smooth bore, and that's all you are. But you can whip it around if you need to. Flow from gallons per minute. I can print this off for you guys if you want it. But, so 1 3/4 at 50 PSI. So, there we go. There's more. So it can be polystyrene. Alright, straight stream. This straight stream and a narrow fog. So fog, the adjustable, you can adjust the cone on it. You can have it coming out almost 90 degrees, or you can zone it in. That narrow fog is going to have more velocity coming out. That wide angle is pretty much just hanging right here beside you. I guess that'd be for a water curtain if you had fire coming down a stairwell or something like that. Now straight stream, it's just one movement on that. Just with discharge patterns. So, like I said, you have the wide one, you can have the narrow, and some of them in combination you can have smooth bore if you turn it. Can provide firefighters with a wide fog pattern. It's used for a variety of applications, variety of nozzle choices and manufacturer options. So there's lots of different types. I know we have several here, but can be used to apply certain type of foam. So yeah, you can roll foam with them. So here's a couple of the different ones. It's the basic fog nozzle, constant gallonages. You can pump it with whatever and just select what gallons you're going to be. Constant, it's gonna give you the same result with the automatic. It adjusts to your gallonage is going to be what it is, and then the constant select. There's another one. I think it's both. Abrupt changes in reaction force of hose lines may throw firefighters off balance. So if you're standing up, it'd be a good time to use your webbing. If you have a 2.5 and you're pushing like that guy was with that 1 3/4, it's gonna be your nozzle reaction, and that's dependent on what kind of nozzle you have and how much water, how much pressure you have. It's a hot one. It's a long day. Automatic fog nozzle. Let's go ahead and take a break. Couple minute break.